The High Fire Podcast is your go-to for straight talk on the steam and boiler industry. Get knowledge you can use, stuff that matters, like tech, safety, industry trends, and more. Whether you're an engineer, a tech, or a plant manager, we've got the info that matters to you from steam industry experts. Tune in and stay fired up. How do you keep a boiler system running safely, efficiently, and out of emergency mode? In this episode of the High Fire Podcast, we get into the nuts and bolts of daily, weekly, and monthly boiler maintenance with our in-house experts.
Well, welcome to Ware's High Fire Podcast. Appreciate you hanging out with us as always and taking the time. I know these are, there's a lot of people that would think this stuff is boring, but there's a lot of people out there that actually love this stuff and will cruise around in vans and going from job to job and have the podcast on. And we can't thank you enough for doing that. Make sure you share those videos for us, get those out there. It does help our algorithms, and we would appreciate it. We're actually talking a little bit about preventive maintenance strategies to avoid some downtime. What we're trying to do here is we're trying to help boiler operators that will, maybe in their maintenance teams, but they're going to understand proactive maintenance strategies. That'll help prevent breakdowns, maybe improve some efficiencies, and also even extend the lifespan of the equipment, which is something that we want to do, is to extend that life of the equipment as long as possible. And being in the rental business, we actually see brand new systems go down after they've spent millions of dollars, and just because of neglect. And that is not good for a business, and we want to help you guys be efficient out there. Gerald, why preventative maintenance, and why is it crucial?
Well, there's a variety of things. Probably one of the more important things to most factories and process is eliminating downtime. Downtime is very expensive for most processes. But if you have a good preventive maintenance program too, you'll lower your repair costs overall. Safety of the environment will be much, much improved. Mm-hmm. And you have a lot less emergency repair.
Yep.
But if you're going to have an emergency, one of the things that we always talk about is make sure you've got contingency plans in place. When you're trying to put in emergency contingency plans, they get very expensive to do. So at least have them in case something does go wrong. Mm-hmm. Things do go wrong no matter what your best plans are.
Yeah.
So the better your contingency plans are, the easier it is on you if something does happen.
Yeah.
Downtime is the real big culprit.
Yeah.
So.
Yeah. Well, you have the downtime, of course, but then without preventative maintenance, you can actually really have some catastrophic things that could even cause fatalities, which is, the episode that we talked about, the pressure vessel. Yeah. That was something that it could have been avoided.
Yeah.
So something very important, obviously, preventative maintenance.
Safety first always.
There you go. That's right. Safety first always. Well, as always, we'd like to have a joke to get things cranked up. So I'll go with one. I would buy anything with Velcro. It's a total ripoff. Bill? No? You don't have any on this one?
I remember, I don't know if you know this about, I'm actually colorblind.
Okay, yeah.
And I remember when I found out.
That's what's going on.
Yeah. I remember when I found out I was 8 years old, and it just completely hit me out of the purple.
Did you come up with that?
No.
Oh, okay. I would say you read that.
The delivery was okay with it. It seemed like I did.
Well, speaking of old and colorblind, still, what do you call an old person with really good hearing?
Huh?
What do you call an old person with really good hearing?
I don't know.
Deaf-defying.
Oh my goodness.
Sorry. It's good stuff. Good stuff. Always good for have some dad jokes. I just crack up. People send them to me now. So if you got some good dad jokes, get them here, and we'll make sure we say maybe who sent them to us. So, well, I know that you can also check out our YouTube channel, Wear Boilers on YouTube, and there's some really good videos out there with some industry professionals talking about preventative maintenance and really the daily, the weekly, the monthly maintenance checklist. But Nathan, let's talk a little bit about daily and what the daily checks need to be.
Daily, I mean, when you walk into that room, you need to check out the water level on the boiler. I mean, that's first thing. When you walk in the room, you need to see where that's at. Next thing you need to be taking a look at is your pressure. And I also check the water level on the feed water system, whatever that may be, whether it's just a feed water tank or DA, whatever you have. Check the water level on that as well. Then, as long as the boiler's firing, take a look. A lot of times, they'll have a front glass on the burner. Sometimes they're really large. Sometimes they're real small. Sometimes they don't have one at all, and you have to take a look through the back. But take a look at it, and as I said before, learn what normal looks like. Because some boilers, the flame always has a lot of orange to it.
Yeah.
And for some boilers, that's not normal, or burners.
Yeah.
Learn what is normal for that. And that way, the day that you walk in there and it looks completely different, something's not right. So it makes it easy to detect things like that. But then, I always tell everybody, don't just rush in the boiler room. And even if you have a checklist to fill out, don't just rush through the checks. And, we talk about it a little bit here and there. A lot of times, instead of wearing earplugs, people are wearing earbuds. Well, if they're doing that and they're listening to music, they're not hearing what's going on in the boiler room. You want to hear how everything sounds. I mean, if you've got pipes that are pinging, you can tell that, something's going on, something's not quite right here. Learn, whenever you're at the burner, I mean, you might, put your hand on it and just feel it while it's running to see, is there excessive vibration here? Is something going on here? Maybe you'll feel it before you hear it. There's all kinds of things to just learn about your boiler room that is specific to your room, that is normal for your room.
We went through the weekly, of course, and one of the things too, and you're always looking for those leaks too. That's something else that we want to make sure we're doing.
Oh, absolutely. I mean, leaks of any kind, whether it be, the water leaks are usually pretty easy because you're going to have to walk through them. Mm-hmm. But you want to, you got water coming out of the boiler, need to probably shut it down right away and start figuring out, what's going on. A lot of times, you'll have a pump seal leaking. Well, I mean, maybe you got a little bit of time on that, but they don't fix themselves. Need to get on it. Need to get, something going. Hopefully you have an auxiliary pump that you can switch over to while you make the repair on your primary. But anytime you have a leak on anything that's pressurized, whether it be a pressure vessel or even, your lines, your condensate return lines have pressure, your steam lines have pressure. Anytime you have a leak on any of that, you need to get it fixed, you need to get it addressed, immediately, because it's not going to get any better. If you have a leak on a flange, a steam leak, it's going to cut that flange. I mean, where right now maybe you can have just a bad gasket. Well, now you're staring down the path of maybe having to cut 2 flanges off and re-weld new flanges on. And that is a significant amount of downtime usually to get something like that done, depending on what type of flange it is, how big it is, and how far up in the air it is. So I said, don't just look down at the ground for water on the ground. You're looking up in the air too. Look for steam, leaking out of something. It might be 20, 30 foot up in the air.
Yeah, you could have safeties weeping, stuff like that. So definitely want to notice those things. And speaking of leaks, as we've been dealing with this a lot of late on some high pressure pumping systems, some pumps are made to leak. And so you do have to understand and know what is normal.
Yeah.
Because sometimes you'll run into a situation with a high pressure pump where it's leaking there, and I don't know if it's your OCD or you don't understand that it's supposed to, and you keep trying to stop it from leaking, and the next thing you know, you damaged all the packing, and then it leaks really bad, and then it stops working. So there are things out there where leaking is a part of the plan, but the point of this is you need to know what normal looks like.
Yeah. And this was our daily checks. I think I said weekly. So see, we do make mistakes, and we'll do it live, and we're good. So, since I am not the smartest guy in the room, I will introduce myself. I'm Richie Ware, and then let's get everybody's name and Bill. I just told your name. Let's move on.
I'm okay.
Bill. Bill obviously has been with us for a long time, but he's actually a veteran now at the High Fire Podcast. You've already done one.
Yeah.
So yeah, you're good. So go ahead, Bill.
I'm Bill Fogarty. I'm the valve division manager, and I'm involved with mostly the stuff outside the boiler and steam system and the condensate return.
I'm Gerald Lane. I'm the Vice President of our Projects and Services Division.
And I'm Nathan Cates. I'm the service manager here at Louisville.
Yep. Awesome. How long you been a service tech? Were you a service tech?
I was service tech for, I guess, just a little over 7 years.
Yep.
And then moved in the office, became service manager.
Yeah. So either you weren't a good service tech, we need to make you a manager, or you're a great service tech.
Somebody retired.
He's a great service
Yeah,
tech.
I'll let you decide.
You made the right choice.
That's right. I think everybody knows exactly what's going on, with how awesome our guys are, and that's a direct correlation with, our leadership, and we certainly appreciate that, Nathan. Well, let's move on to weekly checks, Bill. What do you do weekly?
Be aware of any new leaks in the system, whether it's on the gas side or the steam condensate return. I mean, a leak is if you think of it in simplest terms, that pressure retaining capability of that system is no longer there. It's been breached, so it's compromised. So you have to pay attention to it. You can't just let it leak. It's only going to get worse.
Sure.
And so, maybe on a Monday morning or whatever you come in, your first shift operator, just look and see if there's anything leaking out in the system, be it steam or water or condensate, and around the boiler room. And that's the other thing. It's a good check is if you have a temperature gauge or pressure gauge on the condensate return system, you can tell on a weekly basis if traps are starting to fail. And you'll know that the condensate return temperature, say normally 180, gets up to 190, and then it's going up above 200. You've got traps out in the system that are failing, and it's only going to cause you problems. So those are good weekly checks.
Yeah, and that's a very expensive when that starts happening too.
Yeah.
So there's a lot of opportunity there to save it.
A lot of production losses that happen because of that.
Yeah. Yeah. How do you cut or test the low water cutoff?
Most every low water cutoff, if it's if it's piped, to the outside of the vessel, whether it be a float or probe, you're going to have a valve below it, and you'll slowly open that valve. You don't want to slam that valve open, especially on a system that has a float in there, because you could collapse the ball that's on that float. Well, now that low water cutoff is ruined. So you want to open it slowly. That does a couple things. One, it tests the low water cutoff, but then it also flushes any debris or anything that may have developed in there, and kind of gives it a chance to clean it out. So you want to do that. But then if you have a probe like in the vessel itself, you can't just blow that down. And there is the slow drain or the evaporative test. The evaporative test is a more effective test because that's real. If you do a slow drain, you're testing it, but that's not real world, because typically you're not slowly draining your boiler. So the evaporative test is a little bit more complex, and you really have to know what you're doing and be ready to get water going back to it. But you cut the water off going to the boiler, and you watch and let the water evaporate down. And what you're looking for is, as soon as it is at the bottom of the sight glass, and depending on which code you read, it should be just out of the sight glass or still just in the sight glass, is whenever your secondary low water cutoff trips. And that is Typically, like on a fire tube boiler, that is going to be in the vessel itself. So that's why to test that secondary one, you normally have to do an evaporative test.
Yeah, yeah. This is not for the first guy on the job
No,
to do something like that.
no, because as soon as you've done that, I mean, you've got to get the, you've got the boiler, it's shut down now, as long as the test has went as expected. And that's the other thing, you have to know what a good result is and a bad result is, and what to do when you get a bad result. But, the boiler's shut down, well, now you have to start reintroducing water back to it. You need to do that slowly. One thing I tell, all the new technicians when they come on, so with a boiler, you don't do anything fast. There's nothing that happens fast.
Right.
Yeah, yeah,
Slow.
yeah, yeah.
But I also, recommend testing the low water cutoffs on your feed water systems. There's always, pump cutoff, float, on a lot of the DA tanks and stuff out there like that. And then, they also have some sort of feed mechanism. If it's a float style setup, I recommend, blowing those down, because debris stuff builds up in those, and that's a great way to test it, is by blowing those down.
Right.
True.
And I think sometimes we forget, because we call them cutoffs. These are safety devices,
Correct.
just like any other relief valve and so forth. They all are trying to protect something,
Yeah,
particularly you.
Very true.
right, right. We've been talking a little bit about the vessel, but, what about on the burner set? What are you doing in there from a weekly standpoint?
Weekly, typically you're going to take a look at the scanner. A few things can happen there. You can get dust, debris, depending on what your environment is. It can kind of get on the scanner lens. Fast way to clean that, you just pull it off and clean it with a clean cloth. That's easy. If you end up with, some junk that's gotten in the scanner tube somehow or another, sometimes I use cooling air, and if your cooling air has moisture in it, which it shouldn't, should have dryer on it, but, you can build up, dust and stuff in there as well. An easy way to clean those, most of our techs, they carry a shotgun cleaning kit, and they just run the brush down that scanner tube, fits in there just fine. So, a lot of times, clean those, if you find something, but just checking to make sure that there isn't anything in there is the first part. And then the ignition electrode, taking a look at that, making sure that it's not burnt, the porcelain's not cracked. And then I've seen it's happened, a few times here lately. It's not been easy to catch, because the igniter has a clamp that's clamping it in place. Well, the crack has happened underneath the clamp, and it was arcing out against the clamp. So when you pull out the assembly and you look at it, everything looks great, but it still won't fire up. And ultimately, we just thought, well, we'll just go ahead and we'll change the igniter. We can't find anything else going on with it. We're just going to go ahead. We're going to change it, because we got to try something. And then we pull it out of the clamp, and there would be the crack, and where it had been arcing underneath of it, you couldn't see it. So it was kind of hiding on us.
Yeah, yeah. What about water treatment weekly? Bill, you got anything on that? Just looking for water treatment issues.
Well, I guess one of the things I could relay a story to you about how important the water treatment is. Years ago, I was called down to a plant. They wanted to replace a 5-inch bronze threaded valve gap on their boiler. Well, that's an odd valve. What pressure class is it? They couldn't tell me, so I had to go down and look at it. So I walk in this boiler room, and I see these 2 riveted boilers that are still operational, and I immediately went, "Uh-oh." And so I said, "You guys run these every day?" "Yeah, we run them all the time. They run 7 days a week, 24 hours a day." I was like, "Wow, when were they installed?" But they said 1924. And I'm like, "Oh,
Wow.
they're still running." And he said, "Yeah." He said, "What do they look like inside?" He said, "Look great." I said, "Where do you get your water from?" And he said, "Well, we can get it from the city now. But for 80 some years, we got it from a cistern underneath the borderland." I said, "That's really interesting." And he said, because they were collecting the rainwater, which is soft water, okay? They had a closed loop system, so they had very little makeup that was required, almost no makeup water. And the the water in a cistern loses its oxygen content over a period of time. So they're putting in oxygen that had no, or water that had no oxygen in it. So for 80 some years, the boilers, they opened them up and they were perfect. I mean, the inspector couldn't believe it.
Amazing.
And then when they hooked up with city water, they didn't know they had to put chemicals in it. And so the the boilers immediately got scaled up. And so that's how important water quality is and what good water quality can do. You can maintain a boiler for a very long time if you've got perfect water in it.
Yeah. And on those weekly checks, I mean, you're really looking for foaming, discoloration, as you were talking about in the last episode, right? Just seeing the iron maybe in the gauge glass.
Yeah, I mean, the water, when you're putting it in the system, it should be clear. And if you're, changing your sight glass and, within a week, 2 weeks, a month, it has turned orange, that's the iron that's in your system. I mean, it's either in one of the pressure vessels or the pipes or whatever, and it's leaching that out of it, and it's deteriorating something whenever it's taking that out. So that's just kind of an easy tattletale sign. You don't even have to open anything up. It's telling you right there. You can see it without opening the system up. And then foaming, that can cause a ton of issues with your low water cutoffs and your low water safeties.
Yeah.
And you're going to exercise them a little bit more often than what you should. But now you're running the boiler out of water because the foam will hold the float up and then the foam will collapse. And, the boiler will go out on low water, it shuts down, you have to reintroduce water back into it. And no boiler system was engineered to run that way. That's not how it was set up to run. So now we're potentially introducing slugs of water into the makeup system, and that's harder to maintain to keep removing the oxygen out of it with the deaeration process, because hopefully your DA is sized to handle that. But if your DA is sized for 50% makeup, but you're frequently going down on water and you're calling for these huge swings of water, it's not going to be able to maintain that a lot of times, and you start just snowballing, and it's a domino effect of things that happen after that.
Yeah, and you don't want that foaming carrying over into your process and
Right.
everything else. It affects the whole process then.
We may have some people listening that we're sitting there talking about foam, and they're going, how does foam get in the system? What is that? What is it?
It's an imbalance in your chemical program. Usually, I'm not sure if there's too many other things other than chemical. But once that foaming starts occurring, because it's being over-chemicaled, you're not getting the TDS off the top, which there's a lot of great automated stuff now that does that.
Yeah.
So it'll test for it, and it'll, like our auto flames, for example, you can watch your program, where it is, and watch how it deviates. And we were talking about, if you're not filling out your checklist properly, there's a lot of systems that do inspect automatically, check it, trend it, you can see it over time, and that kind of guarantees that you're getting good information about how your systems operate and what normal looks like. And that would even include whether you had, an analyzer on your system doing temperature, checking O2s. Because a lot of times people say, well, look at my flame, and there are some things where you can say, well, this is what it normally looks like. But that doesn't necessarily mean the quality of that flame.
Yeah.
You can have a beautifully blue flame, and I've seen them and they're running 10% O2, which is highly inefficient. So there's lots of good sensors and instrumentation that you can put on your system to get good trending and keep you up to date with what's going on.
Right.
The other place that foaming can come from, I've seen it happen a number of times, is actually from the process system. If they have a heat exchanger, we had one customers, they were making feed, animal feed, and they got molasses in their system from a bad heat exchanger. And they recognized I got foaming.
Yeah.
It's coming from. But it's real common to get fats back into the system. So that's another place that foaming can occur.
Yeah.
I was thinking about that. There was a site that I had you come out and help me on. it wasn't a heat exchanger, but it was just the way their process worked. When they would introduce steam into their kettle, with the valve opening and closing, they had a check valve fail, and it allowed some of the material that was in that kettle to come back. But then whenever the valve opened, it sent it back through the condensate return line because there was a steam trap right there. And whenever it did that, it ended up in the DA. They were foaming. I mean, there was.
It's a nightmare.
It was. It was a mess. It was a long night.
So if you get that contaminant in the steam system, it's a nightmare to get it out.
Yeah.
Yeah.
It really is.
Well, you have your daily, you have your weekly, and then you also have monthly, checks. Gerald, maybe talk a little bit about the monthly.
Well, you have your combustion checks where you go in, put an analyzer on and see how it's going. And then you've got equipment where we have our analyzers that stay on the systems and check them 24 hours a day. So you have those options as well. And then you get really good trending information about what's happening in the system.
Sure.
And then heat exchangers as well. You'll want to check those, but those kind of keep you on your toes anyways, because when they're not working right, then something is not happening in the process.
Yeah,
So-
yeah.
And then, like I said, boiler logs, they help you help you catch it if you're doing it right, and you're putting good information down. You'll get good information back from it.
Yeah.
Or you have the automated systems, like I mentioned earlier, where it'll trend stuff for you and keep you aware of what's going on.
Yeah, and it's so important, I think, just being consistent with this. With consistency, you'll be able to actually, really see some trends that are going on. You're reducing long-term wear, right? I mean, that's really what's going on, and you'll catch some of maybe the small issues. If you just continue to do this consistently, not pencil whipping, as we talked in the last episode. Because, if you can find the small things will not get big. Small things will move to big. So staying after that. One of the things I know that, again, education is so important to us, with our Ware Boiler University, Gerald, we actually talk about all this stuff in our Boiler University, but we also go to the site and do custom classes on their equipment like this stuff and teach.
We do. A lot of people that come to the school, it's a great foundation builder, but then they'll request that we come in and do custom training specifically on what's in their powerhouse and how they're supposed to go about the checklist and so forth.
Yeah, yeah.
And then, like I said, I think I mentioned in the last episode, we write SOPs for companies all the time because they don't always know what all out there they need to be keeping up with.
Yeah, yeah.
Because the guy that did know, he's gone, and there's a bunch of new guys that just don't have that experience yet.
Yeah, yeah, we can definitely help in those situations, and especially that transition of new personnel that's coming in, but also just get a baseline. I mean, and even some corporations that have multiple sites get consistency across all the sites.
Right.
And you'll start having safer operations, and you also have more efficient operations, and prevent potential problems, which cost companies, corporations a lot of money. So those are whether you're doing it with us or with another trained company, I think it's important to do that. There's nothing wrong with having somebody come in to just give you a good baseline of how do you take care of this equipment. And again, it's not just boiling water. There's so much more critical with a lot of equipment in place.
One of the things you mentioned about the water chemistry, and what I see a lot of people do is if they have two boilers and they only need one, they'll let the one sit. And you got to keep up with the chemicals in the boiler that's sitting as well. And a lot of times what I would recommend to people is, if you're going to run this boiler as primary and the other one is, just your backup, but you want to have it ready to go, you need to, get some sort of program in place that allows it to run for X amount of minutes a day. You need you need to get water out of it. Either you need to evaporate it out, let it make some steam, push it out in the system, you need to blow it down, you need to do something so that it can get new water introduced that's got chemical in it, coming from your feed water system.
Yeah.
In some places, they'll do it, weekly or monthly. If you have, to prevent downtime, if they have, secondary pumps and secondary whatever it may be, switch over to the secondary system and run on it and switch back and forth. That'll kind of spread out your run time, but it also lets you know that both systems are working, like that you can count on it. Because if you switch over to your secondary when you don't need it and you find out that you've got a problem there, no problem. We'll go back to the primary, but now we can go ahead and start getting the secondary, either boiler, pump, feed water system, whatever it is, start getting that resolved. And that right there eliminates a lot of downtime.
There's no doubt that keeping the system running is the easiest way to keep up with it and maintain it. And we know this quite well because we have a 4-boiler live steam school. And it's really challenging because we do turn it off and on a lot because nobody's there every day. And you have to be really diligent about how you handle chemical and how you care for those boilers if they're going to be down a lot. And if you don't have to have them down, that's the best scenario for you.
Yeah.
The other thing I want to add too is not many places have it, but a few places have 2 deaerators. And they'll typically run one 51 weeks a year, and then take the other one and run it 1 week a year when they're doing inspections or whatever maintenance on the other deaerator. And they'll just leave it sit with water in it, which just tears it up. So if you have a spare deaerator, the best thing is to swap them out, run one month, run one the other month. But the month you're not running the one, keep some steam in it to keep keep the water hot. It keeps a little vapor in it, okay? And prevents the oxygen from coming in. Either do that or drain it and put desiccant in it. But you can't just leave it sit there with water in it, because when you go to use it, it's gonna be a nightmare.
Yeah.
It's good. Boiler water treatment and blowdowns. I think this is still, a part of the maintenance, of course, on preventative maintenance. Maybe, Bill, what about why does boiler water treatment, why is it essential?
In terms of the blowdown cycle?
Yes, blowdown or just keeping the water treated well.
Yeah, you have to keep it treated well, not only for the health of the boiler, but the health of the rest of the system. Whatever damage occurs in the boiler can occur in the balance of the system in terms of oxygen and so forth. So, and then within the boiler, you need to blow it down periodically just to remove the sediments. And there's a specific sequence of blowing it down, and in an amount of time you need to blow it down. That's different for each system.
Okay.
It depends on how, whether you have a lot of solids and they come into the system or not. But it's imperative that it's done, and it's done every day.
Yeah.
Sometimes some systems will require it 4 times a day, sometimes 2 times a day is sufficient. But if you don't keep the water in the boiler clean, the steam's not going to be with sufficient quality either.
Right. Gerald, what type of water treatment chemicals are there?
I'm not a chemical expert, but I know you've got your amines and so forth and oxygen scavengers. And then there's some tannins and different types of techniques that other water chemicals companies use.
Right.
And having a great water chemical company is critical. You should really be able to rely on that guy that's coming in doing your stuff.
Yeah.
Which may not always be the cheapest guy in town, but some of the smarter ones are the ones you want to definitely have helping you out.
Yeah. It's worth the extra money to have a good water guy.
Absolutely.
Very important. Well, Bill, you talked a little bit about blowing down the boiler. Nathan, why don't you chat a little bit about the different blowdowns with bottom blowdown and surface blowdown?
Okay, so you have the bottom blowdown, like Bill said, that's to remove everything that has sank to the bottom. And some of the solids that get in there don't naturally sink to the bottom. A lot of times, the chemical that you may have in there is bonding to it to make it heavy so that it does sink to the bottom so you can get it blown out. And whenever it comes to the bottom blowdowns, I would have people ask me all the time, still do today, well, how long should I do the blowdown? And the way that it's been explained to me, and it makes sense, the duration of the blowdown is not really that relevant. It's how often you're doing it. Because if you imagine that you get some solids built up around that hole in the bottom of the vessel where the blowdown pipe is, and you might, remove, a foot or so around it of the solids, but then that's about it. The water's just going to start rushing around, and you may have some debris further out. So, but if you stop and, you come back 4 hours, 6 hours, 12 hours later, next day, they're going to be around it again, and you can get that out of there. So I always recommend, they got to talk to the water treatment guy. That's the guy that is really, in control and telling you, exactly what you need to do. But I've heard all kinds of methods out there, like, well, you want to open the slow first, and then you want to grab this fast-acting night valve, and you want to slam it open and slam it back, or you want to rock the boiler, and you want to have the slow one open. You want to hit the one in the front real fast, and then go to the other side and hit that one real fast, and that's not what you want to do. That you're testing the limits of your blowdown piping and how well it can hold itself together. When you do that, you want it to pick one in the front or back quick opening valves first, slowly. Again, you don't do anything fast with the boiler. Everything goes slow. Open it slowly. Make sure you don't have any leaks. Before you move to the next step, open your slow blowdown valve, and close it back. Close your fast one. Go to the front or the other end. If you start at the front, open it, that quick opening valve slowly, and then go open your slow one again. Repeat the process. And very possible, the once a day on that could be enough, because you also have a surface skimmer, and that's removing everything that's floating on top. There are many, many variations of that. There are automatic ones, there's manual ones, needle valve adjustment. We found that on some of the automatic ones, if you have pretty decent water quality and you're not putting a lot of solids in there to begin with, just the sampling alone is removing enough of the solids that it doesn't even have to do an extra blowdown. Just because, and we've seen it go the other direction, though, where you're sampling too often and you can't even get your conductivity up. So you have to either shorten the duration of the sample or reduce how often it's sampling so that you can get your conductivity up where you want it. But really, it's up to your water chemistry guy. He needs to be the one to tell you this is where you want to run as far as your conductivity level, and then he'll help you develop your blowdown program. And what type of surface skimming setup you have. Like the AutoFlame, it has the surface skimmer, and that's a great setup because you get to trend it, and you get to see it, and you have a history of it. Some of the other ones offer that as well, but the old needle valve on there, that pretty much you're going and you're checking it manually every day and making an adjustment, and it's never perfect. You're always having to adjust it.
Right. Gerald, you love to talk efficiency, and as he's talking, just thinking a little bit about scale. And when scale gets on, tubes or in a boiler, it becomes inefficient.
Oh, significantly. I mean, it's not that maybe a 1/16 of an inch of scale, and you're spending 10% more on fuel. And if you have any size of a system, that's lots of money.
Yeah.
And that's the one, and that comes back to water quality again.
Yeah.
You don't take care of your water, it does damage to your system, it costs you a lot of energy. Because we do all kinds of other efficiency things, whether it be with combustion and controls and so forth. And then just neglecting your water quality, you're throwing all that.
throwing
right
all the
out
money out.
window.
Yeah. Or you could be doing both and doubling up and making a lot
Big-
more.
Absolutely, absolutely.
So, well, part of, just the general maintenance as well, gaskets are something that, is a big part of a boiler in a system. Why don't we talk a little bit about the role of the gaskets, and just maybe the seal in the steam operation? And that, not a animal seal, just a seal, seal, close, tight.
Well, I mean, one of the things that I remember telling a customer once, it takes money to make water hot. And when it's leaking out of wherever it's leaking, you're literally sending money down the drain or up in the air if it's steam. So, I've never seen a leak get better on its own. I've never seen a gasket repair itself. And so it only gets worse from there. It only damages more components if you don't, repair the gasket. But then also, you're wasting money and resources the entire time it's leaking out.
Are you saying you can't put a cheater bar on a pipe wrench and tighten it down and that gasket seal?
I'm not saying that it wouldn't work, but I don't recommend it because you might think you know what the outcome will be, but you don't really know.
Yeah.
That's not something that I would recommend. I've seen people try it, and they went from a small leak to a very, very large leak that completely shut them down.
Yeah, you just smash it.
And there have been cases where people do something like that and create such a bad leak that it kills them.
Yes.
I mean, so doing over leveraging, banging on pressurized systems is
Not a
not
good idea.
advisable.
No, it's not a good idea.
Not a good idea at all. And it's, things that we hear about. So I want to make sure we bring that to light that, that you're having to do that, there's something wrong with the seal.
Right.
It's not made, for that.
It's not just the gasket.
Yeah, that was almost like from the movie, do you saying Jesus Christ can't hit a curveball? That was, you saying you can't use a pipe wrench on a gasket?
But with the gaskets, making sure that the right gasket's installed. You don't want to put, just we call them paper gaskets, but you don't want to put paper gasket on a steam line. I've seen it done, and then we were back, replacing it. And then there are different classes of flanges, and I've seen it's called out for a steam leak, and when I split the flange to change the gasket out, they used a 3-inch, but they used a 150 class, and they tried their best to center it up in there because it wasn't going to center itself like it should have. Whenever they should have 300 class flange gasket in there. So you got to make sure that you're using, gasket that is made, for that use, temperature, pressure, but then also that it's the right class. Because, like I said, you could have, different classes of the same 3-inch flange.
How, like on a handheld gasket or whatever, is that something that, like, there's a lifespan, or do you change those out every year? What's the...
When you separate a flange or anything like that, you should be putting new gaskets in.
Yeah.
You don't go back and they're not made to be reused.
Right.
So
Yeah.
you should be replacing every time you open.
The other thing on the steam system, I see a lot of people will have trouble in particular places in the system where they're replacing gaskets every outage. Okay. Maybe it's at a dead leg where they've got a blind flange at the end of the system. And if you're replacing the same gasket over and over, and maybe trying different gaskets to get it right, typically what's causing that gasket failure is you've got condensate in that portion, sitting in that portion of the system, and it's eating up the flanges. So you can try a better gasket, a different kind of gasket, but nothing's going to work until you get the condensate out of it, because the condensate will chase the gasket surfaces, the flange surfaces, and eventually you'll develop a leak. I've seen it happen in as little as 6 months. and it'll completely eat the faces of the flanges out.
Yeah.
And they're trying to put a better gasket on it. Double
Doesn't
up on
work.
gaskets.
Yeah.
It doesn't work. It doesn't work.
Yeah. There many times you're talking about the man-way gaskets, handheld gaskets, but there's other gaskets on the boiler. Just on the burner doors, steam connections, right? Is it the same thing on like the doors when you're doing open and close? Do you change those gaskets out every time as well?
Yeah, I mean, it could be rope, it could be a variety of different things in there.
Yeah.
Yeah.
Yeah, I know on our open and closes, when we do the preventative maintenance stuff, they're getting a kit. They're getting when they're asking for those things that they're gonna get a kit. I mean, actually, you can actually call in and get a kit for a particular boiler that our guys will actually put together and send those things all over the country for people, just so that they can make sure that they get the proper gaskets, each time that they are open those up. So, something very important to do as well. What are some signs of failing gaskets?
If you can see the gasket, like sometimes the gasket sticks out past the flange or what door or whatever, and you see that it's starting to get hard and brittle. That's a good sign that that gasket is probably getting ready to start to fail. A lot of times the gaskets will start to, especially on boiler doors on fire tube, they'll start to slide out. If there's been any sort of vibration or anything like that, and it's loosened up, those gaskets will start to slide out. A lot of times, people use, on doors what is called tape gasket or ladder gasket, and those seal fine as long as the door doesn't loosen up at all. But if you taking the boiler up and down, I mean, you have expansion and contraction, and they'll loosen up. A lot of times, we won't use the ladder gasket or tape gasket. We use rope gasket because it has a little bit more give to it, and you have a lot less chance of it coming out like that. If, on the combustion side of it, if you're smelling, exhaust gas or anything like that in the room, you take a look and see, why. I've seen multiple cases where, a rope gasket or something has actually slipped out, or liner gasket has slipped out, and it'll be leaking exhaust gas in the room. And sometimes it's not easy to see. Mm-hmm. I've seen them where it's been on the bottom side of a door. So you just, if you went hunting for it, you weren't going to just walk up on it and see it. You actually had to be really searching for it.
Sure. And some of the best practices for replacing the gaskets, you make sure you have your torque guidelines. That's something that's important, as well as surface prep, and even, the right sealing compounds was something else that I know that's very, very important. Well, some final thoughts on this. Structured maintenance plans, they will actually prevent breakdowns and will actually extend boiler life. We've talked several times about, heck, that one boiler in 1924, that's pretty cool that thing lasted that long. There's a lot of old boilers in the United States. And there's a time when these things wear out. But you can make these things work with, get extended life with proper maintenance, good water treatment, and not neglecting. And you can actually make these things last a long time.
Right. And I think what we've talked about too, from the last episode to now, one of the key things, we talked about things being neglected, and they can cause downtime and expenses. But the one thing that neglect does cause, and it'll be expensive for you at the end, is when someone gets killed because you just weren't paying attention.
Yeah. So very important. Very important. Well, that's it for today's Half Hour Podcast. Appreciate you guys hanging out and sharing your knowledge and your wisdom. If you've found any of this good, make sure you subscribe to the channel. Leave us a review. I actually look at those things. I know Chuck is always answering those questions that you have, or maybe you leave a comment, so make sure you leave us a review. If there is something that you'd actually like us to talk about, make sure you send that in to us. We'd love to see that. We'll see you next time on the High Power Podcast.